Okay, so now that we've learned a lot of ways that we can factor, we're going to take it a little bit further. We're going to extend it, and we're going to talk about how we can sometimes have combinations of factoring. So sometimes we can factor polynomials more than once. More than once. So to show you what this means, let's do some examples. Number 1, I have 27a squared minus 12. Now, you might think, well, this looks like two terms that I could take a greatest common factor out of, and you'd be right. So let's take out a 3 from both of these. So I'll have 3, and then in parentheses, 9a squared minus 4. Now you might think, oh, I'm done, I factored, but we can go a step further, because if you look at this part, I have a difference of 2 squares. So we started with the greatest common factor, and now we're going to do another difference of 2 squares. So we're going to take this a step further. 9a squared is really 3a times 3a, and 4 is 2 times 2. So if you remember, we're going to have the 3. We can't get rid of that guy. So we'll have 3 times 3a plus 2 times 3a minus 2. So 3a plus 2 times 3a minus 2. And that's how we can factor that one twice. Let's look at number 2. We have 4b squared plus 40b plus 100. So you might think, oh, this is another greatest common factor problem. I can take a 4 out of all of these terms. And you'd be right. So we'd put greatest common factor, and we'd take a 4 out, and what we'd be left with is b squared plus 10b plus 25. And you might think, I'm done, but it's good to take a good hard look at your solution to make sure you can't factor it any further. And in fact, here we have a perfect square trinomial. So this is a PST. So what I see is that I have b times b here, b times b, and I have 25, which is 5 times 5. And this middle term should be 2 times b times 5. And it is. We have 10b. So this factors out further into 4. I can't forget that I factored it once. 4 times b plus 5 all squared. And that is how I fully factor it. Okay, our third example has 2h squared minus 10h minus 12. Now again, you might see that we have a greatest common factor here. So we'll do greatest common factor, and we can factor out a 2. So we'll have 2 times h squared minus 5h minus 6. And now you might think you're done, but if we look at this, we see h squared minus 5h minus 6. I think I can factor this further. If you think, what adds up to negative 5 and multiplies to negative 6? Well, we have a few options. For negative 5, we could have a bunch of different things. For negative 6, for multiplying to negative 6, I could have 2 and negative 3, or 3, negative 2, or 6, negative 1, or negative 6 and 1. Well, let's see if any of those add up to negative 5. The first 2 pairs do not. The second 2 seem promising. So we have negative 6 and 1. If I have negative 6 plus 1, that's negative 5. So this one's a winner. So this is a trinomial with a leading coefficient of 1. So we have TLC of 1. So we can factor this further. We will have 2 from before, and then we'll have h minus 6 times h plus 1. So 2 times h minus 6 times h plus 1, and that is all factored. All right, number 4 is interesting. We have x squared minus 1. So number 4 is interesting. We have x to the 4th minus 1. Now, x to the 4th is really x squared times x squared, and 1 is 1 times 1. So I have a difference of 2 squares here, and I will get, when I factor, x squared plus 1 times x squared minus 1. Now, if you look closely, x squared minus 1 is also a difference of two squares. That's pretty cool. So we can factor it again using difference of two squares. And x squared is x times x. 1, again, is 1 times 1. So all factored, I need to keep this guy, I can't forget about him. So I'll have x squared plus 1 times x plus 1 times x minus 1. X plus 1 times x minus 1. Okay, let's do a fifth one. So we have a to the third plus 4a squared minus 9a minus 36. Now you might recognize this one as looking like a good one to group, and I would agree. So let's group these terms. Maybe the first and second one here, and then the third and fourth one together, negative 9a minus 36. So these first two terms here have a greatest common factor of a squared. So I pull an a squared out, and I have a plus 4. And then I will have negative 9a minus 36. So I'll have minus for sure. And then 9 goes into 9a and 36. So I'll have minus 9 times a plus 4, because that negative distributes. So when I factor this all out, I will get a plus 4 for sure. And then I'll get these leftover terms, which give me a squared minus 9. Now, if we take a good look at our solution, we'll see that this guy is a difference of two squares. So first we had grouping, and now we're going to have a difference of two squares. So this is a times a, and 9 is 3 times 3. So I'm going to get a plus 4, I'll have a plus 4 from before, times a plus 3 times a minus 3. A plus 3 times a minus 3. Okay, I think we've done enough practice. I will leave you to try the problems at the bottom of your guided notes. Thanks for watching.